Hi guys, my name is Trevor Sullivan. In this video, I wanted to share with you a couple of different techniques that you can use to manage Microsoft Windows Server instances running up in the Amazon EC2 compute service. So one of the services that was recently split out from EC2 back at reInvent 2017 that happened in November of 2017 is the AWS Systems Manager service. So AWS Systems Manager is a suite of different services, and one of the most powerful services that's offered by Systems Manager is called Run Command. So Run Command allows you to deploy commands out to your Linux or Windows EC2 instances that are running in EC2, and you can run things like PowerShell scripts or Bash shell scripts. You can configure patches and lots of different kind of automation tasks. So what we're going to do is run a command through here that actually disables our Windows firewall on a fleet of EC2 instances so that we can then use PowerShell Remoting from my Windows desktop management system here to reach out to those across that PowerShell Remoting channel and gather some information or do some management tasks against those systems using PowerShell Remoting instead. So the first thing we're going to do is switch over to EC2, and we're just going to spin up a fleet of Spot instances. So spot pricing, for those who are unfamiliar with it, basically allows you to bid on unused capacity inside of EC2. And you can experience pretty significant cost savings, sometimes in excess of 70% on Spot instances, and sometimes even more than that. And so what we're going to do is basically just bid on a fleet of 20 instances here, and that helps to just kind of keep costs down. Now, you don't want to typically use spot pricing if you need to run, a 24/7 workload, but it's great for, dev systems, test systems, things like that. So since we're just going to discard of these after we're done, we're going to use spot. So under my Amazon machine image here, I'm going to just select the default Server 2016 instance, and then I'm going to go ahead and switch over to the C4 large EC2 instance here. That's coming in at about 50% cost savings right now. So normally they're approximately 20 cents, but using Spot, we're going to get them for about 10 cents each. And so now we're going to uncheck the C3, make sure we're using C4. And I'm just going to use my default VPC here. I'm going to use the default EBS volume size, so 30 gigs should be plenty. I'm going to choose to launch EBS Optimize just to make sure I get the best throughput for my storage. I don't need any detailed monitoring for CloudWatch, and that's just going to create a bunch of extra metrics for me that I don't really need right at the time being. And you also have a few different choices for interruption behavior. So when your bid price is exceeded in Spot, you can tell it to terminate the instance or stop or hibernate. So we'll just leave that there. Next, I'm going to come just to choose the default security group, and we're actually going to go make sure we reconfigure that to enable a couple of ports. I'm going to use the auto-assign IPv4 public IP address because that's how we're going to reach out using PowerShell Remoting once we've enabled that with the SSM run command. And then I'm also going to choose the IAM instance profile here. So this is basically the IAM role that each of these EC2 instances is going to inherit. And I already have this role created that allows the EC2 instances to communicate with the Systems Manager service. And this is really important because if you don't enable the appropriate IAM policies on your IAM instance profile, then the SSM agent or the Systems Manager agent will not be able to reach out and communicate with the Systems Manager service. So you want to make sure that that's enabled so that your instances are actually being managed once they come up. Now, what's really convenient is that this Windows Server 2016 AMI actually includes the SSM agent out of the box. So as long as we enable this instance profile, it's going to automatically connect out to the Systems Manager service, and we'll see those pop up. So finally, I'm just going to provide an instance tag here just to make these instances easily identifiable. And I'm just going to call this AWS PowerShell, so then I can search for these instances and filter them in the EC2 management console. So let's go ahead and launch this fleet of Spot instances. So our Spot request was successfully created here, and we're just going to wait a few minutes to let these EC2 instances actually boot up and get up and running. Now, meanwhile, I'm going to go ahead and come over to my security group because I'm working in the Northern California region, and I just need to make sure that I have the right ports opened up. Now, if you're working with Windows Server inside of EC2, there's going to be a few key ports that you're going to want to make sure are open. So number one is probably 3389. A lot of people typically use RDP to access their EC2 instances. So RDP runs over TCP and actually UDP, I think, as well. So we're going to do TCP 3389, and then we'll create a separate rule for UDP as well. So we'll do custom UDP rule 3389 and do 0 for now. And then I'm going to set up a port custom TCP. So this is going to be 5985. So this is for PowerShell Remoting. So the Windows remote management service that some of you might be familiar with runs over 5985 for HTTP connections. And 5986 is used for HTTPS connections. Now, HTTPS does require some additional configuration, so by default, only the 5985 port is going to be functional unless you actually set up certificates for your WinRM endpoints. But out of the box, there are no certificates set up, so we need to use the port 5985 there. And I think that should be good. If you're going to run a web server or any kind of process like that you need to access across the internet, make sure you open up port 82, obviously, and potentially port 443 if you've got TLS termination directly on your instances. Okay, so that default security group should be associated with our instances so that when they come up and fully initialize, we should be able to hit things like port 3389 and 5985 and what have you. Now, we're not actually going to RDP into these. I'm just enabling that rule just kind of as a common example. But what we're going to do now is switch over to Visual Studio Code that I'm running here on Windows 10. And I've also got the PowerShell extension installed here. So make sure that you install the PowerShell extension. It's very popular. It's a great way to work with PowerShell from Visual Studio Code. You get things like syntax highlighting, debugging, a lot of other cool features. You actually get a PowerShell integrated console down here that you can run interactive commands from. So yeah, pretty cool. So what we're going to do here is initially on your management workstation, if you're running on a Windows management workstation, again, I'm running Windows 10 here with PowerShell 5.1. We'll just look at PS version table really quickly. So PowerShell 5.1, PowerShell Desktop Edition, which implies it's the Windows version of PowerShell, not the cross-platform version of PowerShell, which is PowerShell Core. And so what I'm going to do is first I'm going to set up what's called the trusted host setting. And I actually need to enable PowerShell Remoting before I do that. So the first thing you're going to do is actually set your network connection profile to private. You can actually skip that step if you add on this skip network profile check parameter, but you do need to enable PowerShell Remoting on your system. And that's going to switch on the Windows Remote Management Service and enable you to make outbound connections to other WinRM services as well. So the EC2 instances that we want to connect to in the cloud. So next we have the set item command, and what we're doing is we're basically going into this what's called a PowerShell drive or a PS drive called WSMan, which is short for Web Service Management, also known as WinRM. And what we're going to do is drill into the client configuration, because what we need to do is we basically need to tell our management workstation here that we trust certain IP addresses. So when we connect to our EC2 instances, we're going to connect to them by IP address, not by DNS name. So what we're going to do is basically tell it that we're going to trust everything. Now, this is not a typically secure configuration because basically what it means is that your system can make outbound connections to any IP address, any DNS name, and it's going to send along your credentials. But rather than specifying all of the individual IP addresses of my EC2 instances, I'm just setting it to star for the sake of this demonstration. Now, next I'm going to use the AWS PowerShell module, and I have a separate video on how to actually install that and set up your IAM user credentials, very similar to the AWS CLI if you're familiar with that. But you're going to call the set default AWS region, and this basically just sets your global region for this PowerShell session so that you don't have to specify the region parameter on every command that you run. So that's going to set it to US West 1, which is that Northern California region. And the next thing that we have here is the get EC2 instance PowerShell command. So this is the one that's going to get a list of our EC2 instances from the region that is configured globally. So let's go ahead and click on this line and hit F8, and F8 is just going to run the line that our cursor is currently on, which is line 8, or if we had a selection, it's going to run the current selection. And so now we've got this variable called instance list, and this actually contains all of the EC2 instances that we provisioned just a moment ago using EC2 Spot. So after a few minutes, those EC2 instances should be all initialized, all ready to go, and we should theoretically be able to connect to them. In fact, let's go ahead and just copy one of these IP addresses and run the terminal services client and try to connect out to it, and sure enough, it's asking for some credentials. Now, in order to actually get the credential, we have to, as you might be familiar with in Amazon EC2, we have to actually decrypt our password using our key pair, right? So you use your key pair to decrypt the password from EC2, and then you can use that password to log in through RDP. Now I'm going to take a slightly different approach here, and I think you'll actually really like what I've done here. So I'm using PowerShell's adaptive type system using the add member command, and I'm taking each of these instance objects that I've stored in this instance list variable here, and for each of those EC2 instances, I'm actually going to append an additional property. So in PowerShell, each object here has a property. So we have the instance ID property, the instance type. We don't actually have to parse this data, right? This is not a representation of just text output. These are actually objects, and they're being formatted for display via text in the PowerShell console. So if you're new to PowerShell, that's what's happening here. And what we're doing is we're appending two new properties. So we're going to append a property to each instance called credential. And so what we're going to do is we're going to construct a PowerShell credential with the IP address of the instance and administrator, which is the username that we want to authenticate as. And then separately, we're going to call the get EC2 password data command. We're going to decrypt that password, and we're going to pass that into the constructor for the credential. So anytime that we reference this credential property, we're actually going to get back this pre-constructed credential object that we can then use in other PowerShell commands that expect a credential object. That leads us into our next property here that we're appending, which is called remote session. So if you're familiar with PowerShell Remoting in the Windows platform, PowerShell Remoting allows us to make an object-oriented connection. It's kind of like SSH, but it's object-oriented. It's built on PowerShell. And what we're doing is we're actually calling this new PS session command to create an outbound connection to the Windows Remote Management Service. And we're going to connect to the IP address. And look at what we're doing here. We're actually going to pass in the credential property that we generated here in this custom property that we just created earlier. And then finally, we're going to give a friendly identifier, a friendly name to the PS session. Now, this isn't a requirement, but this will make it easier so that we can cache the PS session. So after we've already created a PS session, we're going to check to see if it already exists. And if it does exist, we're going to return it from the cache rather than having to create a new session each time. So that'll help improve performance a little bit anytime that we run remote commands against these instances. So I'm going to go ahead and select this code here. And this is basically just going to append these custom properties. So we're not actually going to execute this code until we reference these properties on these objects. But basically, we're just kind of adapting the objects. We're saying, hey, these properties now exist. And when you reference those properties, go ahead and execute the code that's inside of that property definition. You'll see how this works a little bit more in a little bit here. So this line right here on line 21, instance list.remote session, is basically going to go out to each instance in this instance list array, and it's going to try to retrieve the remote session. So what's going to happen is that it's going to reference this property. It's going to try to get a PS session with that instance ID's name. It's going to say, hey, no session has been established yet. So it's going to skip this line, and then it's going to create a new session and return it. So if we tried to run this right now, it would actually fail. So let's go ahead and test that out on a single instance. So let's try to do enter PS session, computer name, instance list, and we'll index and grab the first instance from there, and then we'll do the public IP address. And then for the credential parameter, we're going to specify the instance list item 0.credential property. So this command should fail, and that's because the Microsoft Windows Server firewall is actually enabled by default. So even though we can make an RDP connection out to these EC2 instances, we can't currently manage them using PowerShell Remoting from our management workstation. So what we're going to do is we're going to switch back to the AWS Systems Manager service. Yeah, see, it failed here. So what we're going to do is we're going to switch back over to AWS Systems Manager, and we're going to use Systems Manager to actually disable the Windows firewall. Now, you could, of course, just disable the rule that's blocking WinRM or enable the rule to allow it. But since this is just an example, we're actually just going to disable the entire firewall altogether. So let's go ahead and choose the run command here. And before we do that, let's actually go over to managed instances. I just want to make sure that these are showing up properly. And as you can see, our managed instances are actually showing up here in this list. And you can see each instance ID, you can see its current ping status. This is the SSM, or the Systems Manager agent, that's reporting its ping status. And then we have the Systems Manager agent version showing up here. So of course, since they're all brand new instances, they're all running the same version. We can see they're all running the Windows Server 2016 data center, and of course, all of the computer names. So basically, all of our instances are healthy. They're all reporting into Systems Manager because we assigned that IAM role to the instances that allowed the Systems Manager agent to talk back here. So now that we've confirmed that the instances are actually reporting in, we can come over to Run Command and say Run a command. Now, Systems Manager works off of this notion of what are called documents. And there's different types of documents. There's things like automation documents that work with the automation service. There's State Manager documents. There's Run Command documents. And so when you come into Run Command here, you're going to see a list of the Run Command type of documents. So as you can see, there's a few different useful documents here. If a new version of the SSM agent comes out, you can just choose Update SSM Agent, for example. You can configure Docker with this document. You can configure Windows updates and tell the update agent to actually run a scan cycle. You can configure the Windows Update agent and tell it how its configuration is going to look. But if we come into the next page here, you'll start to see some other related commands, or command documents, rather. So in particular, we have AWS Run PowerShell script. Now, Run PowerShell actually does work on Windows and Linux because the open source PowerShell core now runs natively on Linux, Mac, and Windows. But in this case, we're just going to be running some PowerShell commands on Windows Server that are exclusive to Windows because we're actually manipulating the Windows firewall. Now, what's cool about AWS Run command is that you can either manually select the EC2 instances that you want to run the command on. So I could just check this box here and select this whole batch, come into the next page and select the next batch, and so on and so forth. But it actually has a better way of targeting an array of instances. So if we had 200 and we had to, come in here, go to the next page, check the next set of boxes, and so on and so forth, that's going to be kind of a pain, right? So what Systems Manager allows you to do is actually specify a tag. Now, if you remember earlier, we created a tag called project, and the tag value that we set was AWS PowerShell. So if we simply plug in the tag key and value that we set on those EC2 instances, we can actually target them that way. And so it doesn't matter if we have 20 or 200 or 2,000, we're going to be able to dynamically target only the instances that match the keys and values that we care about. So now now that we've selected the instances that we want to target, the next thing we're going to do is actually specify the commands we want to run. So let's switch back over here to our PowerShell session, and I just want to make sure I got these commands right. We have set net firewall profile, I think. And then we can say set net firewall profile -name. And the Windows Server has 3 different profiles built in. So we have private, public, and domain. And what we're going to do is basically set all of these to false. And that's going to effectively disable the entire firewall. So we're going to do private, domain, and public. We're going to set enabled to false. I think I've got that verbiage right, but let me just double check here. Okay, so we want to do -enabled false. And we're going to get access denied because Visual Studio Code is not running as an administrative user. It's running as a standard user under user account control. So we're actually going to get that access denied message, and that's okay because we don't actually want to disable it on this particular system. So what we're going to do is copy this code here, paste it in, and this is going to be the PowerShell command or the PowerShell script that we want to run on these EC2 instances. Now, when you do a run command, you can also set an execution timeout. So, this isn't going to take more than like 10 seconds to run. So we could do a pretty aggressive timeout, but I'm just going to set the timeout to like 30 seconds just to make sure. You can also add a comment. So, if you have multiple users in your account, your AWS account, you can communicate with those people naturally through the comment field and say, we disabled the Windows firewall for a systems manager demonstration. Okay, so now we've kind of selected all of our options here. The next thing we're going to do is just kind of kick off this command and monitor the progress of it. Now, one of the great things about Systems Manager is that it does run commands in parallel across many instances. So this is only going to take a few seconds to complete, and you can actually see number of completed is already 17. So if we just refresh this page one more time, you'll see that we actually have a very quick success here. So we ran a single command against 20 different targets in a matter of a few seconds. That's pretty cool, isn't it? You can see the exact start and finish time for each instance. So you can see it took about 5 seconds to run, or in this case, 3 seconds to run on that instance. So each instance is obviously going to have its own unique characteristics, but this is a very fast script. Run command deployed this in just a matter of seconds down to the agent that's running on each of those instances. So it's a really, really cool way to interact with your Windows servers. So we're going to switch back over to our Visual Studio Code session now. And now that we have disabled the Windows firewall on these systems, we should now be able to open a PowerShell Remote session or a PS session to these EC2 instances because we opened up the port through the security group in EC2. And then we also used run command to disable the Windows firewall that's running in the operating system. And as you can see here, I've actually got this interactive PowerShell session running on that remote computer. So if I do env computer name, you can see I've got this EC2 instance that we just manipulated using run command. So if we click into our managed instances here or look at the list of instances that was affected here, let's actually switch over to managed instances. And we've got that computer name field over here. And if we try to search for that, it's EC2 AMAS-SNTAEC8. So let's just search for that in the list here. So there it is right there. So sure enough, that's one of the EC2 instances that we just ran this run command on, right? So now let's manage these systems in a little bit more scalable fashion. So what I'm going to do is actually just reference this line 21 here and hit F8. And what that's going to do is it's going to go out, it's going to basically call into this custom property that we added to each of those instance objects. And it's going to check to see if that session exists. It's going to say no, it doesn't. It's going to create a new remote session. And those sessions are actually persistent. So for as long as this PowerShell process is running inside of Visual Studio Code, those PowerShell sessions are going to stay open, right? So if I hit F8 on this line again, those get returned immediately because they're still open in the background, right? So now that we've got these opened sessions out to these 20 EC2 instances, we can start to actually invoke commands against all of these open sessions. So in this case, I'm going to use the PowerShell invoke command, which you typically use to invoke remote commands across PowerShell remote sessions. The -session variable is going to accept all of the remote session, the PS session objects that we just showed here. And that's an array, right? So this remote session property is actually returning an array because we're calling that property on an array object. So it's actually enumerating that array and passing each of those array elements into this session parameter. And then the next parameter we're going to specify is -script block, and this allows us to specify a block of code that we want to run on the remote system. So in this case, our block of code that we want to run is actually just going to enumerate an environment variable called computer name. So if we hit F8, you see almost instantaneously we get back an array of strings that represent the environment variable of computer name on each of those remote instances. In a different example here, we're going to use the Windows Management Instrumentation Service, or WMI, to grab what's called the Win32 operating system class. So there's lots of different hardware and software-related WMI classes, and the Win32 operating system WMI class has a property on it called last boot up time. So if we inspect that property on each of these instances, we can see the last time that they were rebooted. And this can be really useful if you're, investigating some kind of event like infrastructure or application event that occurred inside of your Windows environment. So if we hit F8, you can see we almost, again, instantaneously get back a list of all of the last boot up times from each of these EC2 instances. Really cool stuff, right? So we can actually manage these systems in mass just using these PowerShell remote sessions, or using Systems Manager run command, or use them in conjunction with each other to tell a better story. So that's all I really had to share with you today. I hope this was valuable. If you have any questions, feel free to leave a question in the comments. Leave a thumbs up if you liked this video, if this was helpful. Let me know what helped you out the most, and look forward to the next video. Thanks for watching.